Number 6. Animals can be found in communities of varying sizes, from several wolves hunting their prey to millions of ants working together in a colony. While group size normally varies among different species, it can fluctuate greatly even in the same species. In some instances, such changes can be attributed to habitat. Swarms of locusts are thought to form in places where food and water are sparsely present, meaning that the locusts are drawn toward this precious resource. In other instances, animals in similar living conditions are found to exist in gatherings of various sizes. Fishermen often encounter such variation in their everyday jobs. One day their fishing nets may contain just a few fish, whereas on others it may contain hundreds, with no discernible reason for the difference. People also display a similar pattern, with settlements ranging from small villages to vast metropolises. The difference in size is often attributed to the resources available and the conditions under which they were originally settled.
Number 7. Children are most comfortable when they are in a highly structured environment. This allows them to feel secure, knowing that they can predict with a fair amount of accuracy what will happen next, and that the unexpected is unlikely to occur. Of course, some unforeseen events can catch both children and their adult supervisors by surprise. But it's more often the case that the adults know what is going to happen and simply neglect to tell the children. This is a significant failure of communication, as children have a powerful need to understand the world they live in. When they are unable to do this, emotional chaos dominates their lives. Children make sense of the world through observing the patterns of everyday events and by being given explanations of why changes in an expected schedule occur. By explaining things, adults can reassure children and make them feel valued and informed.
Number 8. Statistics often have the effect of casting a mysterious atmosphere of authority over the conclusions that they are meant to support. But people who lack an understanding of the limitations of charts and graphs, no matter how well-intentioned they may be, can end up using statistics to support invalid conclusions. Clearly, stating that nearly 80% of students answered the math question incorrectly is much more precise and scientific than simply saying lots of students couldn't answer the math question. It is therefore more likely to persuade listeners to agree with a conclusion such as the math question was too difficult. However, without knowing all the details about where the statistic of 80% comes from, we do not know what it means. For example, it could refer only to the students in a class for children who have difficulty with math. Or it might actually be information gathered many years ago that is no longer representative of the current situation.
Number 9 and 10. Before early hominid fossils were first discovered in the late 19th century, scientists had various theories to explain the missing link between apes and humans. Consequently, it was thought that hominids would have a brain larger than that of an ape but smaller than that of a human, and that they would not walk in the upright posture of modern humans. The general reasoning was that no creature could have the ability to stand erect until it had attained a certain intellectual capacity. However, this was disproved with the discovery of small-brained Australopithecines. Despite their brain size, these creatures walked erect, proving that apes had started to evolve into humanoids long before a significant increase in brain capacity took place. In 1876, Frederick Engels proposed that a great evolutionary leap actually occurred after apes stopped using their arms to move around. Walking erect freed up their hands and allowed them to be used for more complex behaviors, such as tool use. He theorized that early humans' use of their hands for labor propelled a rapid acquisition of intelligence, which then led to an increase in brain size. This was eventually confirmed through fossil evidence. Engels was able to reach this conclusion because he was not ideologically biased against manual labor in favor of more intellectual pursuits. Scholars of those days traditionally looked down upon laborers. Engels, however, realized that, due to their prejudice, his peers had failed to recognize the important role of labor in human evolution.